Our solar system races through the cosmos at an unimaginable 370 kilometers per second. This has been known for decades, but new measurements now show that this speed is much too high. In fact, we are moving 3.7 times faster than we should be, and this discrepancy is so significant that scientists now have to seriously consider it.
Whether our fundamental assumptions about the universe are wrong. We're going to take a close look at this crazy story, so make sure you stick around until the end. A warm welcome, everyone.
Speed in space is always a tricky thing. When I say that the Earth moves around the Sun at 30 kilometers per second, it sounds impressive. But relative to what? In space, there is no fixed point of reference, no cosmic coordinate system with an absolute 0 point. Everything moves relative to everything else.
But before we drift off into philosophical musings, why not subscribe to the channel first? Subscribing doesn't cost anything at all. You'll never miss out on exciting astronomical discoveries again, and you'll be helping me out a lot. If you've already subscribed, giving the video a thumbs up really helps. Maybe we can hit 5,000 likes. Thank you so much, everyone. So how do we even measure how fast our solar system is moving? The answer lies in a cosmic tapestry that stretches across the entire universe.
Cosmic microwave background radiation, or CMB for short. This radiation is, so to speak, the afterglow of the Big Bang, a faint noise that comes to us from all directions in space. And because we are moving through this radiation blanket, it does not appear completely uniform. In the direction of our movement, the radiation is minimally compressed and more energetic, while behind us it is slightly stretched. From this tiny discrepancy, a temperature dipole of just 3.4 millikelvin, astronomers can deduce that our solar system is moving at just under 370 kilometers per second.
I always admire what people who paid attention in math class back then are able to calculate. Quite the opposite of me. That's one value. But there's another method to measure our speed, the distribution of radio galaxies.
These distant galaxies emit radio waves, and these waves are also influenced by our own motion. As we move through the cosmos, we should detect slightly more radio sources in the direction of flight than behind us. This is known as the cosmic dipole.
And this is where it gets exciting. An international team of researchers led by Lukas Böhme from the University of Bielefeld has now measured exactly this dipole. And the result is, to put it mildly, astonishing.
For their analysis, the scientists evaluated data from 6 different radio surveys. This included data from the European radio telescope network LOFAR. Together, these surveys cover a large part of the sky and detect radio sources in a frequency range from 120 MHz to 4 GHz. What is special is that the researchers used a new statistical method for the first time, known as negative binomial distribution. Fantastic word for Scrabble. Sounds complicated, it is. High-resolution radio telescopes often show several components of a single galaxy as separate sources. This results in over-dispersion in the data, and the observed variance is greater than in a simple random distribution. The new method takes this into account and thus delivers more accurate results. Böhme and his team found that the measured radiopole, i.e. the speed-dependent deviation in galaxy distribution, is 3.7 times higher than expected. With a statistical significance of 5.4 sigma, this measurement exceeds the threshold at which scientists speak of a reliable discovery. And that is a problem. Lukas Böhme states quite clearly, "Our analysis shows that the solar system is moving more than 3 times faster than current models predict." His colleague Dominic Schwartz adds, if our solar system is indeed moving that fast, we need to question fundamental assumptions about the large-scale structure of the universe.
Wait a minute, you might be thinking now. Couldn't that just be a measurement error? Maybe the researchers didn't pay that much attention in math class after all, and these are extremely precise measurements they're conducting. Mistakes can happen, right? Good question.
The researchers have checked exactly that. The deviations are far too large to be explained by measurement inaccuracies or systematic errors. In addition, various radio surveys at different frequencies all show the same discrepancy. If it were a systematic error, it would have to be consistent across all frequency ranges, and that is extremely unlikely. Furthermore, the current study is not the first to find such deviations. Earlier measurements of quasar distribution using infrared telescopes have yielded similar results. Their findings on the speed of the solar system even deviated by 5.7 sigma from estimates based on cosmic background radiation.
So the evidence is mounting that something really isn't right here and that we actually know nothing about the cosmos. What could be the cause? There are several possibilities, and none of them are particularly reassuring for our current worldview.
First possibility, there is more local mass concentration than we thought. Perhaps there are larger accumulations of matter in our cosmic neighborhood that attract or repel us more strongly than the standard model predicts. Maybe you've heard of the Dipole repeller. It's a huge empty region in space that pushes our local group away, while at the same time the Shapley supercluster attracts us. Perhaps these effects are stronger than we thought. Second possibility, the radio galaxies are not as evenly distributed as we assume. If the large-scale structure of the universe looks different from our models, then this would naturally also influence the measurement. And that brings us to a fundamental problem because our cosmological models are based on the cosmological principle. This principle assumes that the universe is homogeneous and isotropic on large scales, meaning that it looks roughly the same everywhere. If the new measurements are correct, we may need to rethink this principle. Third possibility, there is a previously unknown physical effect that we do not understand. Perhaps dark energy plays a different role than previously thought, or there are large-scale currents in the universe that are stronger than predicted. Some researchers speak of a cosmic bulk flow, a kind of mass flow on gigantic scales and stronger than the standard model allows.
Sounds pretty revolutionary, doesn't it? It is. Because no matter which explanation is correct, they all mean that our previous models are being put to the test. But before everyone starts to panic, this is exactly how science works.
We formulate theories, make predictions, take measurements, and if the measurements do not match the predictions, we have to adjust our theories. This is not failure, but progress. And of course, astronomers have not yet reached the end of their research. More radio telescopes will scan the sky in the coming years and provide even more precise data. The Square Kilometer Array, or SCAR for short, one of the most ambitious radio telescope projects ever, will eventually go online and provide us with a new flood of data. LOFAR will also be further expanded, and with each new publication will provide better information about the distribution of radio sources in the sky. And then there are spectroscopic follow-up observations. With projects like LOFAR, astronomers will not only be able to measure the position of radio galaxies, but also better determine their distances. This will help us understand whether there really are large-scale structures influencing our motion, or whether the deviations have a completely different cause.
One thing is certain, we are living in cosmologically exciting times. The universe keeps surprising us and shows us that we are far from understanding everything. And to be honest, I think that's pretty cool. A universe that still holds secrets is much more interesting than one where we already know everything, isn't it? Of course, I'll keep you updated on any further developments, so go ahead and subscribe to the channel now, and don't forget to give a thumbs up so we can hit 5,000 likes. Thank you so much, everyone. And speaking of cosmic turbulence,
there are disturbing developments not only in space but also here on Earth. At the Campi Flegrei supervolcano in Italy, ground uplift has continued to accelerate in recent months. Scientists are alarmed because there are increasing signs that enormous forces are building up beneath the surface. Are we facing an eruption? You can find out in the video shown above right, and below right, as always, is another exciting video about space and science. Otherwise, I'd say see you in the next video. Take care, everyone.